Hey everybody, so this is our investigation that we're going to do. How we're going to do this is I'm going to step through part of each step. So like there's step 1 right here, step 2, step 3, 4, 5, there's some summaries. It goes all the way through step 7, and then there's practice on the back, okay? So this is a little bit of a long thing. So what I'm going to do is I am going to go through part of each thing and kind of give you a description of what you need to do and also show you what you need to be putting into Desmos. And then I want you guys to attempt it on your own, and I will post a full solution tomorrow on Power School Learning. I need to see that you guys all attempted this. So you guys either need to download this and then write on some sort of editor on the PDF, or you need to print this out and write on it. Or if you would like, you could also write out your own thing on notebook paper with step 1. Just draw a little set of axes. You don't have to do a whole grid. Draw your function, write A. You don't have to write the whole question, but you have to write an answer. And then I need to see you guys post pictures to this. Okay, so what it asks you to do first is graph the following even degree functions. So there are 3 different functions right here. So that means that you need to be doing 3 different graphs. So let's do the very first one. We have y equals 2x squared plus x minus 1. And we get this function right here. Okay, I'm going to highlight my roots and my vertex and my y-intercept. Let's see if I can get all of that up there. I'm gonna unhighlight these and just do my roots first. And okay, and I want you guys to accurately draw this. I don't want you to just like draw a random parabola on there. I want you to draw an accurate one. So I need a point at -1. This is gonna be skinny. That's okay. And I need a point at 1/2. I'm gonna zoom in so you guys can really see what I'm doing. Ooh, there it is. So I'm drawing a point at 1, and I'm drawing a point at 1/2 on the x-axis because those are my 2 roots. And then I'm going to unhighlight those, highlight my vertex, which is at -1/4, -1 1/8. So it's like super close to there. And then I'm going to highlight my y-intercept, which is at 0, -1. So right here. So I should have a parabola that looks something like this. I need at least your roots and either the y-intercept or a vertex. Okay, either one will work for me, or all 3 would be great. So you need to do this for all 3 of these right here. Okay, so you're going to graph all 3. The first part, or the first question, asks you, sorry, let me zoom out. Oh, this is so bad. Y'all know how bad my document camera is. Okay, let me zoom out again. All right, here we go. Now it's super zoomed out. So part A asks you what you notice about these graphs. What do they have in common? Now this was the even degree functions. So that means look at the highest power on each of your polynomials. We have 2, 4, and 6. Remember that 2, 4, and 6 are all even numbers. That's why they're called even degrees. Okay, so answer part A. Then B says the end behavior of these graphs is blank left and blank right. So go back to your vocabulary from yesterday and look at what we did for end behavior. This is going to be up or down, and this is going to be up or down right here. Part C says change the leading coefficient to negative. So you will have y equals -2x squared plus x minus 1. Y equals -5x to the 4th minus 8x plus 2. Y equals -3.5x to the 6th minus x squared minus 3. So I want you guys to, and I'll zoom in on that really quickly. I want you guys to look at the Desmos screen. You're going to go over here. All you're doing is switching that first number to a negative and seeing what happens, and then answering the question, what does that change about the graph? Okay. Then we're going to move on to step 2. Step 2 asks us to graph the following odd degree functions, okay? So it says odd degree, look at the highest power of each of them, 3, 5, and 7. 3, 5, and 7 are all odd numbers. So we're going to graph just the first one, just like last time. We're going to have y equals 1.5 x cubed minus x plus 1. Okay, and we're going to get this function right here. I'm going to zoom in. Oops, that was out. I'm going to zoom in a little bit so you guys can see. Okay, and it might be nicer. I did not do this on the last one, but it would have been helpful if you change the tick marks on your axes. So clearly our function here is like between -2 and 2. And so we don't want this to go out too far. So I'm going to make this my, let's see, 1, 2, 3, 4. Oh, that was a bad line to draw. Let's see, 1, 2, 3, 4. Let's mark it right here. This is going to be my -2. 1, 2, 3, 4. This is my +2. That means this is +1. That means this is -1. Okay. So I just changed my axes, or the little tick marks. I labeled them so that it was zoomed in more, so that I could easily draw my function. So again, first I'm going to start with my root. -1.123. So -1, and then a little further is going to be that one. Then my y-intercept is going to be 0, 1. So I'm going to do up to, this is going to be +1. So right there. And then I want to do this maximum and the minimum as well. So that's almost a -1/2, but a little less. And it goes all the way up to 1.3. So, and that's negative. Okay, so we're going to go like right here. It's close. And then our other one is going to be almost at +1/2, and then at a little over a half right here. Okay, so our function goes like this, okay? And that's all it wants you to do. It just wants you to draw each of those. You can do it using Desmos. I don't really care how it looks as long as you have like points plotted on your thing. It would be really nice if you had your points labeled. But I know that some of them, like this max or this minimum and this maximum, are kind of weird numbers. So it'll be okay if those are left out. So you're going to do that same process for this one and that one. It asks, what do you notice? What do they have in common? It asks about the in behavior again. Again, this is going to be up or down, and this is going to be up or down. Then it asks you to change each leading coefficient to be a negative again. So I'm going to come over here. I'm going to go to the leading coefficient, which is the number in front of the highest degree polynomial. Put a, not a p, a negative sign, and look what happens. Okay, so it's going to ask you how this changes. So I want you guys to go through and answer that question. Okay, let's move on. Step 3. Okay, so in step 3, sorry, it says in Desmos, graph the quadratic function. So I want you guys to graph it exactly as it is written. Y equals x squared plus cx plus d. Then it says under add slider, it's talking about this right here. Click add all, okay? So we want to select those. And then it says play with the sliders. So all that means is you're just taking this number and you're making it bigger, you're making it smaller. You're looking at what changes, what stays the same, okay? So for this particular one, notice there is one point on this graph that stays the same while I'm changing everything. Now, when I mess with the D instead, let me get C back to somewhere where the whole thing is there. Um, I am changing a different part of the function. So